Hi, all of you. Welcome to the online presentation on Geotechnical Lab experiment. In that, we will discuss grain size distribution by sieving. Before explaining the procedure, we will know some theory part of it. We will know some theory part of it. That means grain size distribution curve gives an idea regarding the gradation of soil. That means it is possible to identify whether the soil is well graded or it may be a poorly graded. Particle size distribution is a method of it's a separation of any soil sample into different fractions based on their particle sizes. There is a little possibility of that a soil composed of all the particle of just one size. Soil consists of particle of different sizes in varying quantity. The particle sizes and their distribution in a soil influence engineering properties of soil. The different particle size and their distribution can be determined by mechanical sieve analysis. The result of grain size are widely used in soil classification, soil stabilization, filter design for earth dam, soil compaction. Uh, Grain size analysis by sieving experiment can be conducted as per the IS standards, IS 270 Part 4 1985. What is the aim of the experiment? To draw grain size distribution curve for a given soil and to determine the effective size uniformity coefficient and coefficient of curvature of given soil sample. That means CU and CC of a given soil sample. What are all the apparatus required is listed below. That is the IS standards CUs starting from 4.75 mm CU, 2.36 mm, 1.18 mm, 600 micron, 425 micron, 300 micron, 150 micron, 75 micron, and then the sieve shaker, and then balance of the balance of 0.1 gram sensitivity, brush and riffler. So whatever the things are listed in the next slide I've shown you, these are the list of standard sieves. That means starting from 4.75 to 75 micron, and then the mechanical sieve shaker as shown here, and then the weighing balance, and then the brush, and then riffler, and then here you can observe how you are going to perform the grain size. Very first, what you have to do, you have to arrange the CU, IS standard CU in the order, that is starting from 4.75 to the last 75 micron. Before pouring the soil particle on the tray, ensure that it has started to 0, and then place the tray on the weighing balance, and then pour the soil sample as shown here. You can observe the soil is per year, it is weighing approximately around 1000 grams. Okay, after pouring the soil sample on the tray, this entire soil sample that has to be placed on the IS standard set of seals. Okay, it has to be placed on the IS standard set of seals like this, and then the lid, it has to be placed on the top of the 4.75 mm sieve, and then this entire sieve is to be placed on the mechanical sieve shaker, and then it has to be run for 10 minutes. After that you can observe on each sieve the soil sample is retained, and then weigh the residue retained on each sieve and note down the values that are on each sieve, that has to be tabulated in the tabular column. The tabular column is as shown here. You can observe the mass of the soil sample taken for analysis is around approximately 1000 gram, and this is the tabular column. The particle size, weight retained, percentage soil retained, cumulative percentage retained, percentage finer. Very first, you can observe in the first column, these are the set of sieves, that is 4.75 mm starting, and at the end it is 0.75 micron. And then weight retained, that means as I told you in the earlier, we have to note down the soil retained on each sieve, that is it has been listed over here. For example, how to calculate the percentage of soil, that means if I assume this one as the x1, that x1 divided by the mass, that is x by m, gives you y1, that is the percentage of soil retained. Percentage of raw soil retained. If I want to calculate the cumulative percentage retained, that is p is equal to y1, that is Now, if I want to P2, that is Y1 plus Y2 gives you P2. If I want P3, Y1 plus Y2 plus Y3. If I want P4, Y1 plus Y2 plus Y3 plus Y4. Based on that, I calculated all the values and it has been tabulated here. You can observe. Based on this, you have to draw a graph of that means particle size on x-axis and percentage phi on y-axis on a semi-log. Why on a semi-log graph? Why we have to use semi-log graph? Very important. The size of grain is plotted on semi-log scale because the range of particle is very large. It will be very difficult to plot this range in normal graph. Using log scale, we can represent the whole range of particle size in just one graph. You can observe over here, we have the particle size is on x-axis and percentage of fine are on y-axis. We have to determine the values of D10, D30 and D60 from the plotted graph. You can observe where D10 that is represent the 10% of finer than size, D30 represent the 30% finer than size, and D60 represent the 60% finer than the size. The value based on the value I plotted the graph, you can observe the value corresponding to D10, it is 0.170 mm. In the similar way, the value corresponding to D30, it is 0.310. In the similar way, the value corresponding to 0.60 is 60. This thing is D60 is 0.480. Based on this, we can now determine the CU and CC. CU is nothing but D60 by D10. We know D60 is 0.480 and D10 is 0.170. So if we calculate that, it will come 2.82. CC, the formula is given by D30 whole square divided by D60 into D10. That gives you around 1.18 value. 1.18 value. And you can observe the laboratory based on this value, laboratory classification criteria for coarse grain soil as per IS 1498. As per IS 1498. Determine percentage of gravel and sand from grain size curve depending upon the percentage of fine, that is coarse grain soil are classified as follows. Less than 5%, we call it as GW, GP, SW and SP. More than 12%, it is GM, GC, SM, SC. If it is in the range of 5 to 12%, borderline casing require it dual symbol. For that, I have tabulated a tabular column. You can observe over here. Laboratory classification criteria is given by this tabular column. You can note down. In our case, a percentage of fine is less than 5%. For less than 5%, classification will follow. Is less than 5%. That is GW, GP. SP. In our case, CU is 2.32 and CC is 1.18, which is not meeting all gradation requirement for SW. So our soil, which is poorly graded. So for that, I represent the figure. You can observe over here. It is a poorly graded sand. Thank you.